Safe, dependable, reliable, and tough. These are all words that I've heard people use to describe a diesel engine, and that's exactly what diesels are. You know, looking at diesels and a gasoline engine, there's just no comparison. But in order to be safe and reliable and all those other words we associate with diesels, the engine has to be maintained. And that's what this video is all about. You don't need to be a professional mechanic to keep an engine running smoothly. You just have to have a basic understanding of how everything works together. There are two types of diesel engines. You have a two-stroke engine and then a four-stroke. The most famous two-stroke engine is probably this Detroit here. Since the four-stroke is the most common, that's what we'll be concentrating on in this video. However, let's take a look at the differences between a four-stroke engine and a two-stroke engine. We'll look at this four-stroke one first. This will give you a basic understanding of how a diesel and gasoline engines work in general. As you can see, the first downstroke of the piston draws in air from outside through this open intake valve. The second stroke moves the piston upwards and compresses the air, thus heating it. At just the right time, the atomizer at the top of the cylinder squirts diesel fuel into the cylinder. Because of the heat and the pressure, the diesel explodes, forcing the piston down in what is called the power stroke. It is the power stroke that turns the crankshaft. The piston then moves up on its fourth and final stroke. This valve opens up, allowing the piston to push out the spent gases. The valve then closes and the process starts all over again with the intake valve opening. The flywheel is attached to the back of the crankshaft, and it is a big, heavy disc of steel that helps smooth out the fluctuations caused by the reciprocating motion of the pistons. The two-stroke works on basically the same system, except that the strokes are combined. Starting at the power stroke, the compressed air diesel mixture explodes and drives the piston down the cylinder. As it moves down the cylinder, the exhaust valves open and the piston uncovers ports in the cylinder wall. Fresh air is then blown in by the blower and helps force all of the exhaust gases out. The piston then reaches the bottom of its stroke and continues on up the cylinder, covering the inlet ports. The exhaust valves close. The fresh charge is now trapped inside the cylinder. The charge is compressed as the cylinder moves up to the top where the diesel is injected, and the cylinder starts again. Let's now discuss the various components of the diesel engine, starting with the fuel system. The fuel system has a number of jobs to do. It must pump the fuel from the fuel tank using the lift pump or fuel transfer pump, as it is sometimes called. It's got to deliver it to the fuel injection pump. It is then pressurized and sent to the injectors at precise time sequences and amounts through steel pipes, which are called injector tubes. The injector is forced open by the pressure of the fuel and sprays the fuel in a fan-shaped pattern, much like when you spray perfume out of a bottle. On some engines, like this Detroit, the injector pump and injectors are combined in one unit and located inside the valve cover. Either way, they do the same thing. They deliver clean fuel at high pressure and spray it inside the cylinder at precisely the right time. Now wait a minute. We mentioned clean. Let's talk about that for just a minute. Diesel engines, as we said before, are very reliable, and they're long-lived pieces of machinery. But the components inside, items such as the fuel system, the lift pump, the injection pump, and the injectors, they're machined to very high tolerances, as much as 1/10,000th of an inch. And if any dirt gets into these very precise machine components, well, you know, they'll be ruined, and they will cease to function. The fuel injection pump can also be ruined by water. The machine surfaces inside will corrode. In order to keep the fuel clean, we have fuel filters housed in the supply line. Though one filter is essential, some systems have up to 3 or even more. One of the filters should be a water separator to take care of any water that may condense in your fuel tank or be present in the fuel when you buy it from the marina. The others are strainer and filter elements that can take particles out that are very small. We'll talk more about the maintenance of these items. Oh, by the way, one final thing. You may have noticed that there are 2 lines running from your fuel tank. One is a return line running from your engine. You see, the injector pump delivers a little more fuel to the injector than is actually injected into the engine. This is done for a very good reason. The extra fuel is used to help keep the injectors at a constant temperature. It also helps keep the injectors clean by having a constant flow of fuel going through it. Some engines have a fuel cooler so that the warm fuel that leaves the engine is cooled down so as to avoid causing condensation in your tank when the warm fuel combines with the cold fuel in the tank. The throttle control on your diesel engine is quite complicated. It works in conjunction with the governor to control the amount of fuel available to the injectors at any given moment. And if the engine is under a greater load, it allows more fuel to the engine to maintain that particular RPM. The stop control, on the other hand, usually cuts off the fuel supply inside the injection pump and stops the engine. Some engines have an emergency stop control that is located on the air intake, which cuts off the air supply completely to the engine, thus choking it. There are several types of cooling systems in diesel engines. Like gasoline engines, diesel engines generate an awful lot of heat when they're running. We need to get rid of this heat, so let's talk about how we keep the engine running at a constant temperature and how the entire cooling system functions. If your engine is too cold, it will sludge up. If it's too hot, it'll seize up. So you need to keep your cooling system in peak condition. Diesel engines perform best at a certain temperature. Now, one of the functions of the cooling system is to keep the engine running at this constant temperature. There are three methods of water cooling your diesel. Direct seawater cooling is usually found on small auxiliary diesels like this. The seawater is pumped into the engine and circulated around the engine, and then ejected out through the exhaust overboard, carrying the waste heat with it. The temperature is controlled by the thermostat, which is a little valve that opens and closes according to temperature. This regulates the flow of water through the engine. Another method is keel cooling, which uses a circulation pump to circulate water. Fresh water is circulated in a closed-circuit system. But look at this. As the water circulates, it moves around the outside of the boat where heat is transferred to the outside water. Major components of keel cooling, other than the piping, include the thermostat and the circulation pumps. The other cooling method is called heat exchanger cooling, and it works like this. The engine has a closed-circuit engine system, a bit like the system in your car, where the cooling circulates around the engine using the circulation pump, and it's under pressure. It also uses a thermostat to keep that temperature constant. In your car, the heat is carried to the outside air by the radiator, which transfers the heat of the water in the tubes to the outside air around it. It is circulated through the engine by this pump. It comes in through this fitting over here, through a strainer and through pipes and hoses, to the heat exchanger, which is usually made of a seawater-resistant alloy, most often cupro-nickel. The seawater circulates through these tubes. It carries away heat from the pressurized cooling system within the engine. You may also have a heat exchanger for your transmission oil, and it might also be used to cool the return fuel. The exhaust system carries away all the waste gases, and on a raw water-cooled engine, it carries away all the wastewater as well. Most modern pleasure boats have a wet exhaust system. Now, these can be designed in a number of ways. Here's one way. The gases are on the inside of this pipe, and there is a jacket on the pipe which carries the raw water downstream from the engine. The water and the gases combine in a muffler and are then ejected out the exhaust outlet. This type of system is very good until it corrodes. Then you got problems. The water will find its way from the outer jacket into the inside pipe and may flow back into the engine, causing lots of problems. A more modern type of exhaust system is the water lift system. In this system, exhaust gases are mixed with the water after going through a short section of dry pipe with a bend in it. This bend will stop water from entering the engine. On some boats, you will notice insulation covering the exhaust pipe. If you're going to work on the exhaust system and you have an older boat, be very careful, because there's probably asbestos lagging, which is very dangerous. Now, the modern replacement for this is fiberglass. Another feature of the water lift system is that there will probably be an anti-siphon loop in the water line that leaves the heat exchanger and goes to the exhaust system. Now, this acts as a vacuum breaker to stop water from being sucked into the engine. Siphon loops are also found on marine heads that are also installed below the waterline. It stops the head from filling up with water. This would cause your boat to sink and your wallet to empty. As I mentioned before, diesel engines need fuel and air to operate. The air intake on the diesel is quite straightforward. Air is sucked in past an air cleaner that takes out the dirt and the dust, keeping the air clean. The important thing to remember is that a diesel consumes huge quantities of air, and your engine room must be well ventilated for the diesel to run efficiently and cleanly. On smaller auxiliary engines without a blower or turbo, the air is sucked into the cylinders on each induction stroke of the piston. It's wise to mention a maintenance item that is seldom followed. Keep your air filter clean. On bigger engines and some high-performance diesels, there is a blower or turbocharger installed between the incoming air and the cylinder. The purpose of this blower or turbocharger is to increase the power of the engine by increasing the air supply. The blower consists of a long casing with these vaned impellers. This forms an air compressor. It's important to remember that to gain the extra power, the engines are going to require more fuel. If your engine has a turbocharger, expect it to be more thirsty than the lower-powered cousins. A good lubrication system is important in marine engines. The bottom area of the engine is called the crankcase, and underneath this is the oil pan. This is where the lubricating oil is stored. From here, an oil pump pulls the oil from the pan and pushes it through the engine. Now, once it gets up here, the oil drips back to the pan. Now, while on the way, it will pass through an oil filter that will clean the oil and help get rid of some of the combustion products that find their way into the oil. Acid and sludges are the common culprits. And there often is an oil cooler which keeps the oil at a constant temperature and helps keep its viscosity in the range which is best for the engine. It's important to use the right kind of oil for your diesel engine. Combustion causes carbon and sulfur, which are harmful to the bearing surfaces in your engine. Modern oils contain detergents that help to keep your oil clean, but they do not do that forever, so change your oil frequently and use the recommended oil. Quite different than the one in your car, but just as important, is the marine transmission. Sometimes the transmission is called the clutch or reverse gear, but no matter what it's called, there are only two basic gears, forward and reverse. Many times, reduction gears like this are incorporated to allow the engine to drive a larger propeller. Knowing what makes this thing run isn't going to help much if we can't start it, so let's talk a little bit about the batteries. The most important thing about a battery is that it be powerful enough to start the engine even in adverse conditions. Remember that humidity, temperature, and additional electrical accessories on the boat will affect the energy capacity of the battery. It is also important that the battery connection cables not be too long and that they should be attached directly to the battery. And the terminals on both ends must be completely corrosion-free, as any corrosion will inhibit current flow along the cables. From the energy delivered by the battery, the starter motor begins its job. The starter is operated through a separate solenoid. The solenoid is actuated by either turning the ignition key or activating the starter switch. The battery is charged when needed by the alternator. The alternator is connected to a voltage regulator, which determines how much energy the battery needs in order to be recharged. The voltage regulator is sometimes located inside the alternator. The alternator is run by a V-belt. Alternating current, or AC, is produced by the alternator. Inside, there are rectifier diodes which convert the energy to direct current so the battery can be charged. These diodes are designed to constantly draw energy. For this reason, there is an auxiliary switch which breaks the current flow between the alternator and the regulator, and it is usually incorporated into the ignition switch. So when you turn off the engine, you turn off your alternator as well. Now that you have a basic knowledge of the components of your engine and you know how these parts all function and interact together, let's get to the purpose of this video. Now, that's how to maintain this engine in good running order. One of the most obvious but often overlooked maintenance points is simply keep the engine clean. This way, if there are any leaks or if repair is in order, the problem will be a lot easier to find and the tasks will be much easier. It's also important that the bilges be kept clean. Use a bilge cleaner to keep them free from fuel smell and grease. Before we get specific, let me mention a few general notes of maintenance. Like any piece of machinery, make sure you check the external nuts and bolts periodically to make sure that they're tight. Make sure the mounting bolts are also secure. If you spot an oil, water, or fuel leak, investigate it immediately. Twice yearly, check engine to prop shaft alignment, and maybe most important of all, keep your owner's manual handy. Each system within the engine has to be properly maintained for satisfactory performance. Now, the first area I want to show you is the fuel system. Now, as I said earlier, For a diesel engine to run properly, it's vital to keep the fuel clean. There are several ways to help ensure this. First, only buy from a reputable dealer. Make sure the fuel that you use conforms to the engine manufacturer's specifications. If you buy your fuel from a local marina, it has probably been filtered at the pump. Some fuel tanks have a gauze trap in the fuel tank filter to help filter the fuel even more. A word of warning about filling your tank with diesel fuel. You may have noticed that diesel fuel tends to foam out as it nears the top of the tank. Now this will make a mess on your decks and may even run into the water. Always be careful when fueling up that the fuel flow going into the tank decreases as the tank begins to fill up. If you're planning on taking your boat to the islands or you are cruising in areas where you aren't sure about the quality of fuel available, it's a good idea to carry a strum box or a fuel strainer with you. In a pinch, you can even use a pair of pantyhose. If the fuel has not been kept fresh at the storage tank, you may have all sorts of organisms that are growing in it. So while we're adding fuel to the boat, it's a good idea to add an algicide or biocide. They're commercially available and will help prevent algae growth in your fuel. Follow the particular manufacturer's recommendations for the amount to add. Do this on a regular basis and you can prevent a lot of fuel problems. Remember that dirt in your fuel line can wreck your engine. Most diesels have a primary and secondary fuel filter. You should also have a water separator filter. You have to keep these filters clean and in optimum working functioning order. It's no good to have a filter if it's dirty. Check your water separator daily. Many water separators have a transparent bowl at the bottom so that you can see any contamination. Remember, fuel floats on top of the water, so the contamination will be at the bottom of the filter. To remove the filter element, open the little petcock and drain the fuel into a container. The element should be serviced whenever the bowl shows heavy contamination or at specified service intervals. This is usually every 25 hours. To service a typical water separator, unscrew the filter top from the housing or unscrew the filter body from the mount depending upon which type you have. Pull out the old filter element and insert the new one. Check any gaskets or sealing rings on the body or on the mounting flange. Replace them if they're worn or grooved. Remember, the last thing you want in a diesel system is a leak. No matter how small, it will cause you big problems. If you keep your water separator clean, you shouldn't have to check your primary or secondary filters more than once, maybe every 3 months. But if your engine doesn't have a water separator, I recommend that you get one. By the way, don't forget to check your fuel lines carefully. If they are copper lines, check for any saltwater damage. If they are flexible lines, check them for chafing. Also make sure that they are not too soft or brittle. It's a good idea to change the fuel lines completely now every 3 or 4 years. Diesel fuel contains sulfur, which is a highly corrosive item. Though the level of sulfur is supposed to be regulated, it can vary every time you fill up your tanks. There are 2 common primary filters, the screw-on disposable type and the replaceable element type. The replaceable element type of primary filter is serviced like this. First, turn off your fuel supply. Unscrew the mounting bolt and then gently remove the canister body with the element inside. It's a good idea to perform this operation over a bucket. You'll probably spill some diesel fuel doing this. Next, clean out the inside of the canister body with a lint-free rag and install a new element. On the mounting flange, you'll probably see a rubber sealing ring. Gently remove the old sealing ring using a scribe. Now insert the new sealing ring that should have come with the element. Take care not to twist it. Put the new element in the canister and fill the filter element as full as possible with diesel fuel. This will be beneficial when you bleed the engine later. Now, you want to mount the canister back on its mounting flange and tighten it down. Do not over-tighten. For the screw-on type disposable element, treat it like the oil filter in your car. Unscrew it and remove the old filter. Now, take the new filter, moisten the rubber ring with a little diesel fuel, and screw it back on the mounting. The secondary filter is maintained pretty much the same way. The element itself is made out of a different material, but the servicing is the same. The only easy owner maintenance that your fuel injection or lift pump will need is to be kept clean. You'll also want to make sure that all the connections are secure. A few points you should know before we talk about bleeding your system is that some engines are fitted with a small lever at the bottom of the fuel lift pump. This lever is used to prime the system. If your engine does not have one, it may be fitted with an electric priming pump. It might also have a hand priming pump, but if your engine is not fitted with any priming equipment, you can buy an attachment that will help you prime the engine. I think the best way to go is with an operating or priming pump. The sole purpose of bleeding your engine is to get a continuous flow of fuel with no air in it through the tank to the injection pump and then to the injectors. This is accomplished by making sure there's no air in the filters or the injection pump. You see, diesels have two systems, a low-pressure system and a high-pressure system. Generally, the low-pressure system will not purge itself of air, whereas the high-pressure system will. The low-pressure side consists of all the piping from the tank to the fuel transfer pump, and from the fuel transfer pump to parts of the fuel injection pump. The high-pressure side consists of the other parts of the injection pump, the injector tubes, and the injectors, except on those engines with unit injectors. A typical engine is bled as follows. First of all, make sure that your stop control is in the run position. The water separator should be full of fuel. Remember, there may be a lever on the bottom of your fuel lift pump or hand priming pump. If your water separator is mounted correctly between the tank and the fuel lift pump, and if your electric priming pump is mounted correctly between the tank and the water separator, then it's easy to bleed the system. Crack open the bleed point. Turn on the electric priming pump and you'll see air and fuel bubble out. When you see clear fuel, close the lid. For the primary and secondary filters, the same procedures will apply. Just identify the bleed points on the filters and on the injector pump. Check your owner's manual for the exact locations. Now bleed each section in turn. Begin with the primary filter. Crack open the bleed point until clear fuel comes out, then close it. Then go to the secondary filter, and then finally the fuel injection pump. As clear fuel issues from the bleed points, close each bleed point in turn, starting with the lowest point first. On the injector pump, always make sure that you close the lowest bleed point first. These steps should ensure that the engine is bled. Now your engine should start. After you have found these priming points, it's not a bad idea to mark them with a contrasting luminescent paint. This way you can find them in the dark with a flashlight should you ever be stranded out in the open water at night. It might be necessary for you to turn over the engine a few times with the starter motor while the primer pump is running, so fuel can get through to the lift pump. Normally you won't need to bleed the injector lines. If you don't have an electric priming pump but do have a manual lever on the fuel transfer pump, you follow basically the same procedures. If it is difficult to lift the lever, the engine has stopped with the lift pump drive cam in the full stroke position. You will have to turn it over manually about a half a turn to free up the pump. You may have to fill the water separator by hand until it overflows. Once you've done that, proceed as before, opening all the bleed points and then closing them after the fuel emerges air-free. If your engine is fitted with a manual priming pump, again you will proceed much the same way. The important thing is to simply identify the bleed points. We will now show you how to bleed some of the more popular engines.
To bleed a Perkins engine, you'll need two wrenches, a 5/8 and a 5/16. First point to bleed at is your secondary fuel filter by loosening up the bleed screw on top of the filter. This is a low-pressure fuel pump for bleeding the secondary filter and for bleeding your injection pump. By pumping this lever, you pump fuel from the tank to your filters and to your injection pump. Pump your lift pump down here till you get fuel out, no air. Then tighten your bleed screw. And know it had fuel on. The second point for bleeding the engine would be on the fuel injection pump. Using a 5/16 wrench, loosen up the bleed screw on the side of the pump. Then pump your lift pump till you get fuel out of your injection pump. Retighten the bleed screw. After bleeding the low pressure side of the fuel system, you have to bleed the high pressure side by loosening injection lines up where they go into the injectors. Using a 5/8 wrench, loosen approximately 2 turns. To bleed the 4236 engine, you will need the same wrenches, a 5/8 and a 5/16. On a 4236, this is your low pressure fuel pump. By pumping this lever, you bleed the low pressure side of your fuel system. Bleed this primary fuel filter first at your bleed screw using a 5/8 wrench. Loosen your bleed screw, pump your lift pump so you get fuel out of your top screw here, and then retighten the screw. On a 4236, you have 2 points to bleed on the fuel injection pump. You have a bleed screw here and a bleed screw here. Using a 5/16 wrench, loosen the bottom one first. Pump your lift pump till you get fuel out the bottom bleed screw. Tighten the screw, then loosen the top screw. Pump your lift pump till you get fuel out your top screw. Then retighten. To bleed the high pressure side of your 4236, you loosen the nuts going into the injectors. Loosen the injection nuts going into the first 2 injectors, approximately 2 turns. Roll the engine over with the starter until you see fuel coming out the 2 lines. Then retighten them, and your engine is ready to run. To bleed the 4108 Perkins, you will need a 5/8 and a 5/16. Bleed the 108, first point is the low pressure or the secondary fuel filter. With a 5/8 wrench, you loosen the bleed screw on top of the filter. Then pump the lever on the low pressure fuel pump until you see fuel coming out with no air. Retighten your bleed screw. Next point for bleeding the 4108 is the fuel injection pump. Using a 5/16 wrench, loosen the bleed screw on the fuel injection pump. Then pumping your low pressure fuel pump until you see fuel coming out, no air. Retighten your bleed screw. Next, we'll bleed our high pressure side of the fuel system by loosening up the injection lines going into the injectors. Using a 5/8 wrench, loosen them approximately 2 turns. With the starter, roll the engine over until you see fuel coming out of the injection lines. Then retighten the lines and your engine should start.
To bleed the Northern Lights diesel, loosen the bleed screw next to the fuel filter. Now, operate the fuel priming pump until a solid stream is seen coming from the bleed screw. Once the air has been purged, tighten the bleed screw. Move to the injection pump and locate the 2 bleed screws here. Loosen these 2 and operate the priming pump until you have bled the air from the fuel filter to the injection pump. When you see a solid stream of fuel, tighten the screws. Now, follow the fuel lines to the fuel injectors. While operating the priming pump, loosen the nuts on the fuel injectors. When you have fuel present at the injectors, lock down the fuel priming pump. Now turn over the engine a few times until you see a solid stream of fuel coming out of the injectors. Tighten the fuel injector nuts and you are done. On the 5 kilowatt model, loosen the bleed nut on the fuel filter. Now, operate the fuel lift pump until all of the air is purged in the fuel filter, and you see a solid stream of fuel. Now tighten the bleed screw. Next, open the bleed screw on top of the injection pump and operate the lift pump until a solid stream of fuel emerges. Now, tighten this screw. Let's move on to the injectors. Loosen the nuts on the injectors and turn over the engine a few times until you see a solid stream of fuel. Now tighten down the nuts, and you are finished. On the universal diesel, you will use your electric fuel pump for priming. Loosen the bleed screw on the secondary fuel filter and bleed the engine until a solid stream of fuel is visible from the fitting. Now tighten the screw home. As these steel nuts and screws are set in aluminum housings, care should be taken not to over-tighten these fittings, as they will strip. Let's move on to the fuel injection pump. Loosen the bleed screw at the base of the pump. When solid fuel emerges here, tighten this screw. We now have solid fuel through the injection pump. Further bleeding should not be necessary. If further bleeding is called for, loosen the injector nuts and turn over the engine a few times until solid fuel emerges from the fittings. Now retighten the injector fittings. Care should be taken when working around this area, since the fuel is under a pressure in excess of 2,000 pounds per square inch, so make sure to wear adequate protection. The first thing you want to make sure is that the lift pump has a full range of travel. If you cannot fully operate the lever, bump the engine a few times to rotate the cam. Open the bleed screw on the injection pump. While operating the lift pump, observe the fuel emerging from this fitting. When you have a solid stream, tighten the screw. The engine should now be fully bled. However, if the unit still won't start, it will be necessary to bleed the injectors. Loosen each fuel injector nut and turn over your engine. When solid fuel is present at the fitting, tighten and move on to the next injector. This will fully bleed the fuel system. To bleed your Yanmar diesel, open the bleed screw on the fuel filter. Now operate the lift pump until a steady stream of fuel emerges from the fitting. Open the screw on the injection pump and operate the lift pump until all air is purged from the fuel system. Then tighten the screw. Now follow the fuel lines from the injection pump to the injectors. Loosen each nut and turn over the engine until a solid stream of fuel is present at the fitting. Then tighten the nut back. To bleed the Kohler diesel engine, first open the bleed screw on the fuel filter. Next, operate your fuel pump until a solid stream of fuel is seen at the bleed screw. Now tighten the screw. Still operating the fuel pump, open the bleed screw on your injection pump. After you have purged all of the air, tighten the screw. Follow your fuel lines up to the injectors. Open the injector fittings one at a time and rotate the engine until solid fuel emerges. Then tighten the fittings. To bleed the Caterpillar diesel, open the petcock and operate your fuel pump. When solid fuel emerges, close the petcock. Open each injector nut and operate the fuel pump. When the air is removed from the line, tighten the fitting. When you have bled all of the fuel lines, the engine is ready to operate. In bleeding the Detroit diesel, make sure your primary fuel filter has fuel in it. Now connect your fuel pump to your secondary fuel filter. Disconnect your return line and place it into a container. Next, operate your fuel pump until solid fuel emerges from the return line. The way to determine if your engine actually needs bleeding is to listen for injector creak as you start the engine. This sound is made by the injectors at the moment of injection. You can also feel it as a knock in the appropriate fuel line. If you hear it, you can dispense with the whole bleeding process because fuel is actually reaching the injectors. So if your engine is getting fuel and won't start, then it's got to be the air supply that's the problem. The diesel engine requires enormous amounts of clean air to run efficiently. Most engines have an air filter or cleaner to help purify the air taken in. Keep these clean. Like the fuel filters, they are no good if you don't. Some of these elements are washable or cleanable. Some are replaceable. Do whatever is required by your engine. If your engine has a turbocharger or blower, and if the turbocharger has a special oil filter, make sure that this filter is clean and replace the elements as often as the manufacturer recommends, following the maintenance procedures in your owner's manual. The main problem you can have with your engine's exhaust system is deterioration, so it's important that you just check for this problem periodically. Replace any flexible hoses and clamps and any other parts which might have become worn. Check any insulation for cracks and repairs, or replace as necessary. The most important thing is that you have no leaks. As I'm sure you know, changing the oil and its filter is very important to prolonging the life of this engine. If you use your boat often, you should change the oil and the filter twice a season or more. If you only occasionally use the boat, once a season is usually sufficient. Don't neglect this though. Dirty oil is damaging to the bearing surfaces of the motor. First of all, let's drain the oil. I like to have the engine a little warm so the oil drains easier. To drain the oil, undo the drain plug in the sump if it's accessible and let the waste oil run into a suitable container. If it's not accessible, you can drain the oil through the dipstick tube. On some of the bigger engines, you'll find an oil drain point handily mounted on the side of the block. All you have to do is open a valve or two depending upon your model, and pump the oil out manually or electrically, depending upon the type of installation. You notice we're wearing gloves because the oil is warm and you don't want to take a chance of getting burned. After we finish draining the oil, it's time to change that grimy filter. Some mountings are threaded and the entire unit unscrews. Sometimes you have to use a filter wrench. After you have removed the filter, discard the element and wipe the mount clean. If it is a screw-on replaceable element with clean oil, wipe the rubber sealing ring on the new filter to lubricate it and screw it on hand tight. Use your filter wrench to tighten it 1/4 turn more, but don't force it. If the element is inside the canister, take out the old element. Clean it out and then install the new element with any appropriate gaskets or sealing rings. It's a bit like changing one of the fuel filter elements as we described before. Now reassemble it and tighten it. Now let's replace the oil. Always use the grade of oil specified by the engine's manufacturer and just pour it in like this. Don't forget to add an extra 1/2 to 1 quart of oil or more, depending upon your oil filter size, to compensate for the amount of oil you lost when you changed it. The next system we'll check is the cooling system. Regularly check the water level if you have a closed system. I like to check it about every time I start the boat. To check the coolant level, remove the header tank filler cap, which looks like the radiator cap on your car. Notice I said coolant. It's not good for any engine to run on just pure water. It's much better to run on a mix of coolant and water. Sometimes people refer to the coolant as antifreeze, but whatever you call it, it contains lubricants and anti-corrosive agents which help keep your cooling system in peak condition, and it aids to lubricate your water pump. Depending upon the geographical area in which you have your boat, the coolant-water ratio will vary. A good rule of thumb is a 50-50 mix. Now, with the cap off, check your level. If you're down on coolant, look for a leak. We'll be covering cooling system problems later, so if you think you have a leak, keep watching. Before you replace the header tank cap, look at it and see if it is in good shape. Check the rubber gasket and make sure it is in good condition. Because your engine heat builds up pressure in the cooling system, it's not a bad idea to buy a lever-type cap with a pressure relief valve like this one. This way, if you have a problem and have to remove the filler cap while the engine is hot, you can release the pressure safely. If your engine is raw water cooled, you should have an impeller-type water pump. On some smaller diesel engines, the water goes through the transmission housing first, but usually the pump will be found mounted either in the front or the back of the engine. To locate the pump, follow the intake water hose through the through hull, past the strainer, and here it is. Now, let's look inside the water pump. turn off your through hull and remove the cover plate from the pump body. There are usually 4 to 6 screws holding it on. Inside you'll see the impeller blades. See them? Carefully pry out the impeller with a flat-edge screwdriver. Sometimes needle nose pliers will work. Whatever you use, be gentle. Now that the impeller is out, I look for any kinds of scrapes or cracks that might show impending impeller failure. I usually do this once a season. This one looks fine, but if it had any damage at all, like this other one, I would replace it. I always recommend carrying a spare. These look fine, so we're now going to reinstall them. We'll just go in reverse. Here's a little tip though. Before you push the impeller back into place, apply a little bit of liquid dish soap to the blades. Now, put it in. Put on the gasket, replace the cover plate, reopen the through hull, and you're finished. Not so bad, was it? If you notice that the pump itself seems to be leaking, call your particular engine dealer and ask them if the pump can be rebuilt. Sometimes they can, depending upon the make. However, if they can't, simply buy a new one and reinstall. If your system has zinc anodes to help prevent corrosion, check them every 3 months or so. They're usually located near the water pump or on the heat exchanger itself. To replace them, simply unscrew the plug they're attached to, remove whatever is left of the old anode from the plug, and screw in the new one. Screw it back into the water pump or heat exchanger like this. Now this little bit of maintenance can save you an awful lot of headaches. As I mentioned before, your heat exchanger is made of a copper-nickel alloy. Well, as strong and as sturdy as it may be, it is not corrosion-proof. By using this little zinc anode as a sacrificial piece of metal, it can literally save you hundreds of dollars in buying a new heat exchanger. If your engine is running at the proper temperature and your coolant is clean, then your thermostat is probably working just fine. The thermostat is located right here. There's really not a whole lot of maintenance you can do on it other than replace it when it goes bad, and you'll know when that happens because your temperature won't stay where it ought to be. Now what happens if you open your header tank filler cap and notice that the coolant is filthy? The answer is obvious. You have to clean it. It's not really a big job. There's a drain plug on the side of the engine which will allow coolant to spill into the bilge. Drain the system with the filler cap off, and then wash it through with fresh water until the drainage comes out clean and clear. If your coolant is very dirty, you may have to use a chemical cleaner. In that case, follow the instructions on the package. Once the drainage water is clear, replace the drain plug and refill the system with a 50-50 coolant water mix. Now you may have to bleed the water system if there are any high points in the engine where air can be trapped. You can do this by squeezing the hoses as your engine runs. You should really only have to change and flush your cooling system once every 2 or 3 years. I mentioned earlier about this raw water strainer. If you don't have a strainer, it's a good idea to install one. It will keep a lot of debris from entering and possibly damaging your cooling system. These strainers are usually transparent so you can see a buildup of debris. The important thing is to check it regularly and keep it clean. To clean the strainer, simply turn off the through hull. Open the lid or clamp on the strainer housing and remove the strainer basket. Many times you can just clean it with your hands. After you have cleaned the basket, reinsert it. Check the housing gasket, and if it looks worn, replace it. Don't forget to reopen the through hull. If you have a leak of coolant, you'll notice it really easily. Coolant is usually green, and a small leak at a hose clamp or a gasket will be noticeable. If you're losing coolant and cannot find the leak, it's usually one of 2 things: a leak in your heat exchanger or an internal engine leak. Sometimes you can find the heat exchanger leak by looking at the exhaust water. If you see green in it, that's where your coolant's going. Take off the heat exchanger by unbolting it and removing the hoses. Then take it to your local radiator shop and have them pressure check it for leaks and see if the tubes are plugged. This is also a common cause for what's called engine temperature creep. Sometimes they can solder it and repair it. On the subject of heat exchangers, if your transmission fluid suddenly looks like milk or strawberry soda, then your transcooler is leaking. And if you suddenly get lots of water in your fuel, then it's your fuel cooler. Fix those heat exchangers right away or replace them. Another way of finding a heat exchanger leak is to take off the header cap when the engine is not too hot, but warmed up. Be very careful not to get scalded. When you do this, look inside the header tanks and see if the coolant water is bubbling a lot. If it is, then your leak is probably not in the heat exchanger, but in the cylinder head gasket or in the cylinder head itself. If it's not bubbling, there's probably a hole in the heat exchanger. A cylinder head or gasket leak will often evidence itself in hard starting or white smoke, as the water turns into steam when running. The cure is to pull the cylinder head and gasket and make the appropriate repairs, a job you'll probably want to leave to the mechanics. The other kind of engine leak usually manifests itself as water in the oil from bad cylinder liner seals. The water leaks out under pressure into the oil. The cure is a rebuild. Engine temperature creep, which we mentioned before, is caused by a number of factors, the most common one being a blockage in your C strainer. The other cause, a gradual plugging up of your heat exchanger. See these two examples? Notice how this one is nice and clean. It can conduct all of the heat to the raw water as it passes through the heat exchanger. This other one, however, is scaled up and cannot properly pass heat. Over time, your engine temperature will slowly creep, and eventually you'll have to clean out your heat exchanger. This heat exchanger has removable end caps so that you can inspect the core rather easily. If you see signs of scaling or plugging, take your heat exchanger to the local radiator shop for a thorough cleaning, as they're the ones best equipped to do this job. Let's move on to the transmission. First, you should check that there are no transmission oil leaks and that the oil level is maintained. The oil in the gearbox doesn't get contaminated by combustion products, so it doesn't need to be changed too often. The elements in any fitted filters should be changed according to the manufacturer's recommendations, just like we change the oil filter. Make sure these breathers on top of the casing are not blocked. Most transmissions use hydraulic fluid, while others use the same oil that you use in your engine. Make sure you put the correct type and grade of oil into your transmission. If you have any doubt and can't find the correct specifications in your owner's manual, call your dealer. They'll be glad to assist you. Check your fluid every time you leave the dock. Most hydraulic transmissions are normally checked in neutral. If all of a sudden you see milk or strawberry soda, look at your oil cooler. Also keep an eye on the hoses to the cooler. They're high pressure and you don't want them to leak. Check the controls on the gearbox once a season. Make sure all the clamps and cable connections are tight and functioning properly. If you find anything wrong, fix it now. If you don't, you might later find yourself losing control of your boat. While we're on the subject of transmission control, some engines are fitted with a neutral safety switch, operated by the gear shift. Every time you start your engine, make sure you are in neutral. If you don't, the engine won't start. Let's look at the engine starting battery. You always want to have a battery powerful enough for the job. Check with your owner's manual to find the right size. When you buy a battery, get the one that has the longest guarantee. Don't skimp. Buy a respected brand name designed specifically for marine use. Believe me, it's worth the extra pennies not to get stranded out on the water somewhere. Most boats will have 2 or more banks of batteries. One bank is just for starting. The others are for the boat's accessories. However, no matter what the battery is for, it should be properly installed in acid-proof boxes. They should also be connected to a battery disconnect switch such as this one. This switch connects all the batteries together, with the starter motor to give you additional cranking power for those times you might need it. Long cables can reduce the amount of voltage that reaches the starter. If they're ever chafed or corroded, replace them immediately. And of course, you know how to keep all the connections clean. If you have corrosion present, sometimes you might as well not even have a battery. When you leave the vessel, it's not a bad idea to turn off the battery switch. However, for flotation safety, make sure that your bilge pumps are still connected to the battery through an automatic switch and not disconnected at the battery disconnect switch. You never know when a battery is going to go, so I try to keep from getting caught off guard by occasionally checking the batteries with a hydrometer. It's best that the outside temperature is around 70 to 80 degrees Fahrenheit. Even if the temperature is lower, the specific gravity will read high. If the temperature is high, the specific gravity will read low. However, if there's no charge, there won't be any reading. Here's how you do it. Take the cap off the cell. Draw out some water and then take a reading. This one's fine. If you find that the charge is low, take the battery to a service center and have it charged. If it won't take a charge or loses it quickly, then guess what? It's time to get a new battery. There are marine battery chargers that can be installed so that your battery stays charged when not in use. Some are automatic and some are adjustable. These need to be set correctly for your particular battery. You never want to overcharge. When checking your battery charge, check the fluid level also. If it's low, add water. Distilled water is usually recommended, but if that's not readily available, any water is better than none. Expect the charge to drop a little initially when adding additional liquid. We'll continue our inspection, but first I'm going to turn off the battery switch. This will prevent any accidental shocks. Graphite helps prevent corrosion, so rub a bit on the ignition key and insert it into the switch a few times like I'm doing now. Now, take a look behind the panel where few men dare to go. Look at all the wires that lead to the ignition switch. Make sure the insulation around the wires isn't damaged and that all wires are well secured. Check your engine's belts every few weeks or so. Use your finger to test the tension. Always keep extra belts. You never know when one's going to break. To change a belt is quite easy. You usually just have to loosen the alternator bracket, swing the alternator in, remove the belt from the pulleys, and replace it with a new one. The size of the belt is usually marked on the top of the belt. Write down the number and keep it in a safe place. This way you can always get extra belts at the marine store without having to take off the old belt and measure it. Install the new belt, swing the alternator back, keeping tension on the belt, and tighten the bracket again. After running the belt for a few hours, check the tension again. Adjust it after you've run 1 hour, and then readjust it after you've run 8 hours. A new belt is prone to stretch. Hoses are especially subject to wear. Some of these carry water, others fuel and oil. But whatever they carry, you need to make sure that they're kept in optimum shape. The first step is to squeeze them. If they feel soft or mushy, they'll need to be replaced. They'll also need to be replaced if they become brittle. Take a piece of the hose you're replacing to your marine dealer and have him match it for you. This could save you a trip or two to the store should you get the wrong hose because you were guessing. Make sure your hose clamps are of marine grade and are made of stainless steel. Be also sure that the screw on that clamp is stainless. To check to make sure that they really are stainless steel, use the old magnet trick. If it sticks, they're not. It's a good idea to use 2 clamps any time that you have a connection below the waterline. This way the boat won't sink if one clamp fails. Make sure that all the clamps are secure, but don't over-tighten. During your yearly inspection of the engine, check all of the electrical connections. Just follow them around as you would a road map, making sure that all the wires are secure and in good condition. Just a word of caution. The diesel is strong, but it's also delicate in some ways. You should never alter the injection pump timing, injector setting pressure, or fuel pump setting without the proper knowledge or equipment. The manufacturer's original settings should always be maintained. Unless you live in a part of the country where the climate is warm year-round, you'll probably want to put your boat into hibernation for the winter. That's the time to begin thinking about winterizing your engine. Your engine's enemy is not overuse, but lack of use. After all, left alone without proper winterizing, your engine can deteriorate worse than it would with several seasons of hard use. Here's what you'll need for winterizing your diesel: a pump-type oil can, a supply of lubricant for the transmission and crankcase, oil filters, and a can of spray rust preventative. Before the boat is hauled, change the crankcase oil as I showed you earlier. Make sure that you dispose of this properly and that does not mean in the water, but of course you know better than that. Replace the oil filter and add fresh oil. Be careful here not to spill oil in the bilge. What a mess when that happens. Now, crank the engine up and let it run a few minutes to distribute the oil. Acids and moisture build up in used oil. The purpose of changing the oil now is to prevent rust and corrosion from building up inside the engine while it's sitting quietly. If your raw cooling pump uses a flexible neoprene impeller, it should be removed for the season. If so, just open up the pump and remove the impeller like we did before. Next season, you can easily reinstall it or replace it with a new one. Fuel oil deteriorates when it sits. So whenever I winterize my engine, I like to pump or drain all of the fuel oil from the fuel tank. It lightens the vessel, and that way I can start my new season with fresh fuel. If you drain the fuel, remember that the next season you will have to bleed the system. Air could enter the supply pipe or siphon tube. But you know how to bleed the system, so that's no problem, right? If you don't want to bother with draining and bleeding, you can skip this procedure by adding an inhibitor to the fuel tank. Either is okay. Drain the cooling system. Close the drains and then fill the system with a 50-50 mix of water and antifreeze. Run the engine for about 5 minutes to distribute and mix the solution. You want to eliminate all plain water in the engine to prevent any type of freezing. Normal winterization requires putting a couple of ounces of oil into each cylinder. To do this, sometimes you have to remove the injector or glow plugs. It's not that difficult. The glow plugs will typically just screw out, and you can use a long nose oil can to pour the oil in. Then simply replace the glow plugs. However, if you have to remove the injectors, you may need a special tool, and you will most certainly need a new seating washer. Look at your owner's manual or ask a mechanic before you start removing the injectors. While it's a simple process, there are so many different kinds that there is no way we can cover all of them in this video. But whatever you do, don't knock or damage the atomizer end of the injector when you take it out. Do not wipe any carbon on the tip with a rag. It may plug holes. After you have put the oil into the cylinders, turn the engine over about a dozen times, but don't let it fire. You can do this by having your stop control engaged so that no fuel can get through the injection pump. Now, don't crank the engine again until it's recommissioned. After the engine is shut off, spray some rust inhibitor into the air intake. Make sure the engine is off. You don't want the inhibitor going through the engine. Left in one spot, your V-belts and bearings will develop flat spots. We can keep this from happening by taking the tension off the belts by loosening these bolts. It's best to remove your battery from the boat while it's in storage. Take it home and keep it charged during the winter so that it will be in great shape for spring. Test it with a hydrometer just like you would if it was still on the boat. Check and fill your transmission as we talked about before. Spray the back of the instrument panel with water repellent. You want to keep all those connections clean and dry. To provide a final coat of protection, spray the entire engine with a rust inhibitor or a light oil. For final protection, cover the entire engine with a loose canvas tarp. That will let the engine breathe. In other words, avoid vinyl or plastic. After your engine's long winter's nap, you'll want to recommission it. Check the electrical connections, clamps, pipes, hoses, belts, and cables. Make sure they're supple and in generally good repair. You never know what can happen during the winter. Then, even though you're anxious to get out on the water, try to hold your horses and go over the points I showed you in the maintenance section of this tape. This will help you to make certain you have a great season of boating. Under the best circumstances, things can go wrong. Engines and their parts will wear out and break down. And usually they do this at the most inopportune times. You know what I'm talking about. Hoping that nothing ever does go wrong, let's go over some of the things that could possibly happen and then discuss their probable causes. Let's troubleshoot. What if your engine won't start or it has difficulty starting? The first thing I'd check is my battery. It could be that your battery is not holding a charge. The first thing to do is to have it tested. If that's the case, buy a new one. But let's say that you've had your battery tested and it seems to be fine. The most obvious problem is that there is an electrical leak somewhere. In this case, the leak should be repaired as soon as possible before it completely drains your battery. To find the leak, the simplest way is to go out on a dark night or in a darkened engine room, start up the engine and look for sparks. If you see any, check the system in the vicinity of the sparks and repair the leak. However, this doesn't always work. In that case, you'll need to do something a little bit more scientific. You can make your own device for testing electrical leaks quite easily. You'll need two pieces of wire, an appropriate voltage light bulb, and a socket. Just put them together. Now, take the positive terminal off the battery, turn off all circuit breakers, or if your boat uses fuses, remove them. Connect one of the wires to the positive battery terminal and connect the remaining wire to the battery clamp. The light should not glow. If it does, you haven't turned everything off. Assuming the light doesn't come on, you now close each breaker or replace each fuse one at a time. When the light glows, you know you've discovered the source of the leak, or whatever it is that is powered by that breaker or fuse. Now just repair it. Okay, suppose that's not the problem. Probably then something is wrong around the regulator or alternator and the battery isn't being charged properly. First, check the belt tension. If it's loose, tighten it. But if the belt is tight, then it probably is a problem with the connections between the alternator, regulator, battery, or switch. If you don't find a problem in the connections, then you might have a faulty alternator or regulator. If it is a faulty alternator or regulator, we can narrow down this culprit by connecting a wire from the battery's positive post and the alternator's field terminal with the engine running. If the alternator begins charging like crazy, you know it's your regulator. If there is no change, it's probably the alternator. However, check with your alternator manual before you attempt this procedure. It could be possible that you may fail to identify the field terminal properly. This will damage your alternator and the regulator and can even cause a fire. So be very careful. Now let's go back to the battery. Sometimes batteries dip because they don't retain enough water. If your battery uses too much water, it might be that the battery is getting too hot. Shield the battery compartment from any heat source and install a vent or blower to help reduce heat buildup. If heat doesn't appear to be a problem, the charge rate is probably set too high. If your voltage regulator is adjustable, you can solve this problem by reducing the charging rate on the regulator by 1/2 volt or so. Some regulators aren't adjustable, and you'll have to buy a lower output regulator to achieve the same effect. Obviously, we're starting with the battery because that's the obvious thing to suspect when your engine won't crank. But there are a few other things to consider if the engine won't crank. One thing could be your starter motor. Here's how to test your starter motor. Using a meter or test light, check that you have power coming from the battery to the starter motor solenoid. Using a pair of jumper cables, connect across the solenoid like this. You should hear the starter motor turn, although it won't engage. To check to see if it would engage, disconnect the jumper and use a small piece of wire and hold it like this across the incoming battery power and the solenoid terminal. If you hear the solenoid throw the pinion forward, it means the starter will engage. Using both sets of jumpers, you should be able to get the starter motor to turn and engage at the same time. This means that if your starter motor is working, the problem is in the wiring from your starter switch. If the starter motor is not working, take it off and get it to a starter shop for repair or replacement. But let's assume the starter is working fine, but the cranking speed is low. Check your electrical connections. You might even want to take the starter off, take it to a repair shop, and let them load test it on the bench. If you know the starter is fine, check the lube oil. It could be too thick, especially in cold climates. If it gets very cold where you boat, you might want to put a preheater on your engine or change to a lighter grade of oil. Some engines are fitted with a decompression lever. This will make it easy for your starter motor to turn your engine even in cold weather. Other causes of low cranking speed could be in your cables. Should you ever crank your engine and happen to notice that the battery cables or connections become warm, stop immediately. It means that your cables aren't big enough. You have a poor connection, or both. If your engine is cranking fast but still won't start, the first thing to check is that your stop control is off. It's amazing how many times this little fellow is the culprit. If it's an electric control, make sure that you haven't activated it accidentally. Remember, the stop control stops fuel from passing through the fuel injection pump. As long as it's on, you'll never start. Now, I want to mention at this point that if your engine is old, tired, leaks oil, blows a lot of smoke, or simply is in not good mechanical condition, there could be many causes why it won't start other than the ones we're about to discuss. These could all be related to various engine components such as valves, rings, cylinders, and gaskets. However, because of the limited scope of this video, I'm assuming that we have an engine in relatively good condition that just won't start. After I checked the stop control, I would move on to the air intake to see if I could find some blockage. Some engines have an air flap that is used as an emergency stop control, and these could have accidentally become engaged. Many newer engines have a solenoid-operated fuel shutdown valve, which are in the closed position when the engine is off. When the ignition switch is turned on, they become energized and open. If there are any problems in the electrical system, the solenoid valve will automatically shut off the fuel supply to the engine. Most solenoid valves are mounted on or near the fuel injection pump. You can check their operation by checking the power supply to the solenoid. You should hear it click on and off when you disconnect and reconnect the power. Surprising as it may seem, check the fuel tank to make sure you have fuel and that the fuel supply valve is open. Check the fuel water separator or primary fuel filter to see that they are not plugged or full of water. If they are, replace all the filters as we discussed earlier. Sometimes the fuel lift pump has a screen inside the diaphragm housing. Sometimes this screen will become plugged and won't pass fuel. You can check this quite easily by undoing this center bolt and removing the cover. Assuming the filters are clean and that you have fuel, the next step is to find out if you have air in the fuel lines. Remember, your diesel won't work unless it has clean, airless fuel. If you suspect air in the system, bleed it as we described earlier. Sometimes you can bleed the engine and it will start, but then it will die again immediately. When that happens, you obviously have a pinhole leak somewhere in the fuel system. Most of the time you will discover your problem between the fuel tank and the lift pump. That's the only part of the system that is under suction pressure. If the engine dies immediately, it could also be a filter that has not been properly snugged down. To find out, start with the line from the water separator to the lift pump. Disconnect it at the water separator. Place the line in a jar of clean diesel below the level of the lift pump and operate the lever on the lift pump. If the fuel comes through without air bubbles, replace that line and go to the next one, back toward the tank. Keep repeating this process until you've isolated the leaky fuel line, valve, or seal. If after all of this you still can't get your engine started, you might as well take out your wallet and start counting. You've probably got a worn fuel injection pump or worn injectors. The only other thing it could be is incorrect fuel injection timing. The timing won't go out by itself unless it was incorrectly timed after a repair or some other mechanical failure, such as a stripped gear, in which case you should have had other indications that there was a problem. A tip you might want to be aware of is that many engines are fitted with cold start devices called glow plugs. These are like small heater coils. They help get the engine started by heating up the combustion chamber and igniting part of the atomized diesel fuel. If your engine won't start, you may be tempted to use starting fluid. Let me caution you against that. I know it's the easy way to get old Betsy running, but starting fluid can ignite at the wrong time inside your engine. It can cause serious damage to the pistons and to the piston rings. Leave it in the store. Let's look at some other problems we might have with the engine. If all of a sudden you're going along and you experience a loss of power or the engine stops, it usually means a restriction in your filters. This can be caused by contamination in the fuel. The first thing to do is clean the filters, rebleed the engine, and proceed. If this happens over and over, and you have alternately checked for other leaks, and you know the fuel you are using is clean, it could be that you have a contaminated fuel tank. There are several remedies. One way is to buy a new tank. But other than that, there are proprietary tank cleaning services that will come to your boat and wash out the inside of your fuel tanks. It actually works. It's called fuel polishing. It also has the added benefit that you don't have to throw away the existing fuel. A quick tip, if you're having a problem bleeding your engine underway, is to turn on the fuel priming pump while you're cranking the engine. This will increase the fuel pressure and help push out any air in the system. Another cause of losing power could be that your engine is overheating. Be sure to keep an eye on your temperature gauge. If you notice you're overheating, stop immediately. If you don't stop your engine in time, it could seize up. It's not a bad idea to install an overheating alarm or flow detector in the cooling system. A diesel engine should run about 180 degrees Fahrenheit with a pressurized cooling system. If your gauge suddenly reads high or you smell trouble when you're underway, stop the engine and let it cool until you can touch it. If there's a ruptured hose, you'll probably see it. A saltwater leak can generally be stopped by turning off the through hull or plugging the exhaust. A freshwater leak won't sink your boat. Then you can identify the leak. If it's a hose, replace it or even patch it with electrical or duct tape so you can limp home. Don't go out on your boat without a spare belt and the tools to work on it. A broken belt can be changed in no time if you have a spare. No belt? Then use a piece of line tied off with a square knot or a piece of rubber inner tube. Always make sure that you have enough water on your boat to put in the cooling system should it be required. You can always add the coolant later. If you have a blockage in the water strainer, clean it out and always carry a spare impeller on board, along with the tools you would need to replace it. We discussed replacing the impeller earlier in this tape, along with some of the causes and cures for overheating. One of the things that many people complain about is the smoke emitted by a diesel engine. Normally, the exhaust should be perfectly clear, just like a gas engine. But if your diesel does begin to smoke, you can pretty well narrow down what's wrong with it simply by the color of the smoke. Let's go through the various colors and determine the probable causes. Black smoke is unburned carbon from the fuel system that is coming out of the exhaust. It usually comes from bad injection or an overloaded engine. It could also be the result of a dirty air filter. If your injectors aren't injecting properly, then the fuel that they push out dribbles into the cylinders and doesn't burn properly. It then comes out of your exhaust as a big black cloud. If your boat is improperly propped, you can cause an overload condition quite easily. Overloading is not good for your engine. It will lead to engine failure in a very short period of time. If you have a new boat and you get a lot of black smoke, it's unlikely that the injectors are defective in your new engine. Go right back to the dealer. Tell him to check the prop size of your boat. If you don't, the engine will not live very long. Sometimes, if the engine compartment is poorly ventilated and the temperature of the incoming air is high, it will cause black smoke. It's just the same as having a restricted air intake, because the density of the air is less when it is hotter. If all of a sudden you get black smoke when you are accelerating that eases off as the boat approaches speed, it is usually an indication that your boat needs service. Now, blue smoke is mainly caused by one thing, that's burning oil. Oil finds its way into the combustion chamber, either down the valve guides or the stems, and past the piston rings. Both of the items are serviceable, but are beyond the scope of this video. There are a couple of other causes as well. If you have an oil leak on your turbocharger, the oil will get sucked in with the incoming air. Or if you have too much oil in the crankcase, it will get pushed into the combustion chamber by the crankcase pressure. Make sure you have the right oil level. Now, white smoke is usually water in the fuel, a defective injector, a cracked cylinder head, a leaking cylinder head gasket, or a lack of compression. This can be caused by the leaky head gasket. Make sure that there is not water in the fuel and no leaks or cracks in the cylinder head or gasket. If your engine is running rough, it's a good idea to find out which cylinder is causing the problem. Now here's how you do it. Start the engine and loosen the injector nut at each injector. Do this one after the other. Diesel fuel should come out of the loosened nut and the engine should slow or change its rhythm. If the engine does not change its rhythm when you loosen the nut, it is safe to assume that the cylinder is not firing, either because of a defective injector or other mechanical problems such as bad valves. If no diesel is coming out of the injector nut when you loosen it, then now you'll know what to look at: a bad fuel pump. Also, check for dirty fuel or a restricted air intake. Remember, fuel is the lifeblood of the diesel. If the engine won't pick up, chances are it's not getting enough fuel. Check your filters. Check for clogs in the line. Make sure that you have fuel in the tank. One of the most common problems with diesels is water in the crankcase. If this happens, it is probably one of two things. It can be a leak in the cooling system, and if that's the case, have a mechanic look at it. However, if that's not the case, make sure you always warm your diesel engine up to its optimum temperature every time you use it. If you don't, you create enough heat from the engine to produce condensation, but not enough heat to burn it off. Thus, you end up with water in the crankcase. So, if you can't take your boat out all the time, at the very worst, tie it off at the dock with some very strong dock lines, start your engine, make sure nobody's in the water, and then put it in gear in the slip. If you do this, make sure the dock cleats are strong enough to hold your boat. If all of a sudden you go down to check your oil and you find the oil level in your crankcase is higher than it was the last time, you've got a problem. Deal with it immediately. Either you've got water leaking from the cooling system or diesel leaking from the engine. This is most common in engines where the injector lines are inside the valve cover or cylinder head. Diluted oil is a major cause of engine failure and should be dealt with immediately. You can also smell diesel in the lube oil. Oil pressure, whether it be high or low, is a major concern to diesel engine owners. A good way to keep an accurate check on your oil pressure is to have two gauges. Most engines nowadays are equipped with an electric gauge that measures electrical signals from the oil sender. However, as with anything else that is electrical, it can fail. Sometimes the old manual ways are still the best. If your engine does not have one of these manual oil pressure gauges, you might want to consider installing one, rather than relying on an electrical signal. This gauge actually measures the pressure of the oil as it moves up a slender pipe toward the gauge itself. By actually coming into contact with the oil, it is obviously more accurate. If you experience low oil pressure, there are several things you should check. Look for damaged or worn bearings, insufficient oil in the sump, an inaccurate gauge, a failing oil pump, a pressure relief valve sticking open, a broken pressure relief valve spring, a faulty suction pipe, a choked air filter, or a blocked sump strainer. If the oil pressure is too high, check for an inaccurate gauge or a pressure relief valve sticking open. To check the pressure relief valve, which is located on the side of the block on most engines, unscrew it and check the spring and plunger. If there are any signs of wear or breakage, replace them and set the spring to the factory recommended setting. There is a certain amount of knock and vibrations that go along with owning a diesel engine. Sometimes you can troubleshoot the engine by listening to the specific type of knock coming from it. We already talked about injector creak previously, but other noises you can hear are the tapping of the rocker arms, or as they are properly called, tappets, against the valve stems. If they sound real jangly, it means that the valves need adjusting. If you don't hear them at all, you better take off your valve cover immediately and check your valve clearances. Set your valve clearances to the factory settings found in the owner's manual. Sometimes you'll hear a rumble. If that happens, get out your wallet, because a rumble means that the bearings are wearing out. If you hear a low-frequency knock, it could be the bottom end of your connecting rod. One way to differentiate between the knock of fuel igniting and mechanical knocks is to run the engine at full speed and then close the throttle all the way down. The fuel knock will stop at once, whereas the mechanical knock will continue. Diesel knocks are normal. We can all hear that delivery truck coming from 2 blocks away. It's the abnormal ones we need to keep our ears open for. You made a wise choice when you purchased your marine diesel engine. It's very reliable and it's efficient. And if it's well maintained, you'll have very few problems with it. What we've tried to do in this videotape is to give you some basic information about how your diesel engine runs, what it consists of, and how to keep it properly maintained. Then if you do have a problem now and then, you can troubleshoot it and avoid unnecessary repairs and worry. Sometimes it's the simplest things that give us the biggest problems. I hope this video has highlighted what might have been some very confusing or unknown factors for you about your engine. Just remember, take care of your engine and it'll take care of you. It'll get you there. Happy cruising. The minimum tools you should carry on board is an adjustable end wrench, slip joint pliers, a pipe wrench, a vice grip, a set of screwdrivers of various sizes and heads, a set of box end wrenches, a hammer, flashlight and spare batteries, electrical or duct tape, an ohm meter or continuity tester.